Hello everyone, and let's talk about some more numerical problems of set theory. So, what I'm going to discuss here is majorly like the rule of how many number of elements in the union. So, I'm going to use the fundamental rule like number of elements in X union Y. So, if X and Y are two sets, you can think about it. They are given by number of elements in set X plus number of elements in set Y minus number of elements in X. Okay, I just have to rewrite it. Just a minute. So number of elements in, I would say, X and Y intersection. So in for mathematics generally union is actually referred as or generally goes with a plus sign. And when I talk about intersection, then it is generally treated as and generally goes with a product sign. So that's exactly something which you'll be using, when you're going to do the problem probability or something. So this is X and Y or X product Y, something you can understand like that. But so that's a little symbolic representation here. So yeah, I've been given a question if X and Y are two sets such that number of elements in X are 17. So I've been given that number of elements in X are 17 here simply, plus number of elements in Y are 23, and number of elements in X union Y are 38, and I want to find out how many elements are in X intersection Y. So this becomes a really easy arithmetic problem. Now you can simply switch the places. Probably you can multiply by -1 both sides, or perhaps you can take, let's say, an X union Y. If you shift it on the left side of the equation, and this is going to become 17 plus 23 minus 38. And if you solve it, then simply this is 40 minus 38, and that becomes 2. So that is the first problem for you, where you have applied a very simple concept to find out the number of elements in X and Y. And let's see another problem. There's a group of people which has been given to you, and it has been said that okay, 400 people are there, 250 can speak Hindi. So let me represent number of people speaking Hindi by NH. They are given by 250, and 200 can speak English. So number of people speaking English I'm representing by E. They are exactly 200. And it has been said in a group of 400 people. So number of people speaking Hindi or English, that's important to understand. They are 400. Now, how many people are there who speak both Hindi and English? Both means number of people who speak Hindi as well as English. That is exactly what I want to find out. The question becomes really simple now. I have been given, and I know the relationship here, Hindi or English, number of people speaking Hindi plus number of people speaking English minus number of people speaking Hindi and English. And if I want to find out Hindi and English, then it is going to be number of people speaking Hindi, number of people are speaking English, minus number of people who are speaking Hindi or English. And I hope now the things are very easy here. I can simply see that number of people who are okay speaking Hindi are 250, number of people that are speaking English are 200, and number of people speaking Hindi or English are 400. And if you solve this result, it is simply going to give you a result called 50. That means there are 50 people who are actually speaking Hindi and English both. Let's see the next problem again on the same concept here. And this problem again specifies, if S and T are two different things which are being given to you, two sets, and the set S has 21 elements, so NS has 21 elements, T has 32 elements, and it's been given to you that number of elements in set S and T are 11. So how many elements are going to be in S union T? This is rather easier problem. You don't have to even switch the places. So number of elements in S union T would be given by number of elements in set S plus number of elements in set T minus number of elements in set S and T, and that is simply going to be okay, 21 plus 32 minus 11. So I can see that in S, T and S how many elements are there, and it is simply 53 minus 11. So I hope you can easily identify now. 42 are the number of elements in S union T. Let's see one more example. This says if X and Y have two sets such that X has 40 elements, so number of elements in X are 40. X union Y has 60 elements, so I've been given with X union Y, number of elements in X union Y, they are 60 numbers, and number of elements in X intersection Y are 10. Then I have to find actually how many elements are there in Y. So this is exactly what I want to calculate. I'm going to use the same formula. Number of elements in X union Y is equal to number of elements in set X plus number of elements in set Y plus number of elements in set X intersection Y. And I know X union Y is 60. I know number of elements in X are 40. Number of elements in Y I want to calculate, and number of elements in X intersection Y are 10. Okay, this is minus. My mistake. I'm sorry. Let me just correct it. So now it is absolutely fine. Now you can simply see 60 is equal to 40 minus 10, that is 30 plus number of elements in Y. And this shows number of elements in Y are going to be 60 minus 30, and that gives you a number 30. Let's see another example. There is a group of 70 people. 37 like coffee, so I'm writing it C as coffee. Number of people liking coffee are 37. That's a given information. 52 like tea, so number of people liking tea are 52. Let me just get rid of it. And another information which is given to you is that in a group of 70 people, so fundamentally number of people in liking coffee or tea are 70. So how many people like both tea and coffee and tea? So I just simply has to find out both coffee and tea. That is exactly what I want to find out, and I hope you can solve it further. So now let me write it in a very quick way. Number of people are in like coffee, number of people like tea minus number of people like coffee or tea, and I've driven it from the same formula. So I've taken union on the right hand side and actually taken intersection on the left hand side. Now it is going to be the people liking coffee are 37, people liking tea are 52, and people like either coffee or tea are 70. So it is 89 minus 70, and that gives you there are 19 people who like both the beverages. That means tea as well as coffee. Let us see the next question. I've been given in a group of 65 people, 40 like cricket. So I'm going to write it something like this. Number of people liking cricket are 40. 10 like both cricket and tennis. So number of people like tennis and cricket, let's say. They are 10. How many like tennis? So the first thing I need to find out is, just a minute. First thing I need to find out is how many like tennis. This is how many like tennis. And second is how many like tennis only, not the cricket. So I want to find out like tennis but do not like cricket. That is exactly what I want to find out. Two portions. So this how many like tennis only and not cricket is right here, and how many like tennis only. So let I think this is a problem. There are a group of 65 people. So the people like tennis or cricket are 65. So it's an easy proposition to find this one. We have already done it. So let's find this thing first. That how many people like tennis. So number of people liking tennis or cricket is equal to number of people like tennis plus number of people like cricket minus number of people like tennis and cricket. So that simply is going to be 65 is equal to this. I want to number of people liking tennis. I want to find out. Number of people like cricket has been given 40 and number of people like tennis or cricket is given 10. If you do a little arithmetic, it is pretty simple. It is going to come out to be 35 people like tennis. So I have got the answer for this thing. Number of people like tennis is 35. Let me see another portion. Number of people like tennis but not cricket. So I'll use a particular result which has been discussed earlier also. That T minus C, that means people, okay, this is C, this is not B, my correction. So again, I just have to make a correction. I'll just clear it, rewrite it. See, union, tennis and cricket is going to be tennis. So you can see it from Venn diagram here, pretty simple. This is T, let's say, tennis. This is cricket. And T minus C, that means the elements which belong to T, not a part of C. So that is T minus C, shaded portion. Union T intersection C. And this dotted is T intersection C. So this is T minus C. And this is T intersection C. And if you see their union is T only. Same way, if you see their intersection, there is nothing common between T minus C and T intersection C. So if I write T minus C intersection T intersection C, that is phi. I can use either of these results to find out my answer. I'll use the first one. So I'll put n on both sides. That means number of elements in T minus C. That is exactly, I am using this particular result here. Number of elements in T minus C plus, instead of union I'm using plus. I have already told you number of elements in T intersection C is equal to number of elements in T. So what I did is, in this equation I have added number of elements on all the sides. So number of elements in T minus C, that is what I want to find out. So this is exactly what I want to find out. Number of elements in T intersection C, I already have 10, and number of elements in T also I have already calculated 35. So if you see, number of elements in T minus C are going to be 35 minus 10, that is 25. So there are 25 people who actually like tennis only but not the cricket. So that means this 35 may have some people who also like cricket, but so 10 people are there who actually are common like tennis and cricket both. So that's how the problems related to uh, union of the sets, or in fact I would say addition theorem of the sets, can be solved. Thank you very much.